This video describes how chemists use the table of relative strengths of acids and bases to predict acid-base reactions. Systems may have different entities flowing around in them. Fortunately, the Bronsted-Lowry theory tells us that the predominant reaction will take place between the strongest acid and the strongest base in the system. There is a 5-step method for predicting the predominant reaction. The first step is to list all of the entities. Ionic compounds will split into their positive and negative ions. Ionic oxides will give cations and hydroxide ions. Strong acids will give hydronium ions and a conjugate base. Weak acids will remain as their molecules or ions. Weak bases will also remain as their molecules or ions. The second step is to look at each entity and decide if it is an acid, a base, both, or neither an acid or a base. Hydronium ions are the strongest acid that can exist in aqueous solution. For this reason, if a strong acid is put in solution, it will be written as H3O+ and the conjugate base. Strong acids are listed on page 8 of your data booklet. They are all of the acids that appear above hydronium ions on the table of relative strengths of acids and bases. Strong bases can be recognized because they will be metal hydroxides. These form hydroxide ions and cations in solution. For step 3, identify which of the entities is the strongest acid and which is the strongest base. All of the acids are listed in the first and second columns of the table and are ranked from strongest to weakest. All of the bases are written in the third column of the table and are ranked from weakest to strongest. Once the strongest base and strongest acid are determined, an equation between them should be written. The strongest acid will donate a hydrogen ion to the strongest base. The conjugate acid and base will be the products. The final step is to determine the position of equilibrium. If the strongest acid appears above the strongest base in the table, then the products will be favored. If the strongest acid appears below the strongest base in the table, then the reactants will be favored. Here is an example of how these 5 steps work. Sodium hydroxide and vinegar are reacted. The question asks if the reactants or products will be favored. The entities would be sodium ions, hydroxide ions, acetic acid, and water. Hydroxide ions are basic, acetic acid is acidic, and water can act as an acid or a base. On the acid-base table, the acetic acid is highest up, so it is the strongest acid. The hydroxide ion is lowest down, so it is the strongest base. A balanced equation showing the proton transfer and conjugate acid-base can be written. The strongest acid appears above the strongest base on the table, so the products are favored. We show this by writing greater than 50% above the equilibrium arrows. Please complete the December 10th quiz.